Alright, so I failed to make the combineTrees method over the week, and it's Friday now, last day. Just showing off what I've gone through combineTrees. I was just on Skype talking to Lynette and trying to come up with like a really long and complicated idea, but here it is. So the combineTrees method basically gets your initial forest of trees and takes the trees with the least frequency, least two frequencies in that array, and combines them together, where the left child will be the tree with the lowest frequency and the right being the second lowest frequency. And to do that, you have to figure out how to find the min tree. And what I'm doing here is I'm traversing through the array of uh, Huffman trees to find the lowest frequency, and I initialize the min tree to my tree 0, which basically means you start at the very beginning of the forest. And anyway, the min frequency will be the very beginning, like the frequency at the very beginning. And basically, I'm just making a check variable to look through every single frequency in the forest and just setting it equal to that. And I'm for sure taking its index equal to k so that I'll know where to place the combined tree later. And it's also so that I can swap the tree. And I'm swapping the tree here. I'm basically saying once I find my for sure minimum value, you're going to set the temp tree equal to the last tree, temp tree just being a placeholder. And you would set the very last tree in the forest equal to the min tree, and your index, which you get from here, equal to the temp tree, which is your last tree. So you'll see it's a pretty clean swap. And after you swap, you're going to decrement number of trees so that you can get rid of a tree once you combine everything together. And to find the second tree, it's about the same thing, same swap. You put it at the end. Yeah, if you want to take a look at that, go ahead. And basically, to make a new Huffman tree, you have to have a new symbol frequency packet. And basically, the new symbol frequency packet takes in a list and a sum, and the sum being the min frequency and second frequency. And this new list getting all of the symbols from that tree and putting it into a new one, kind of like that. And anyway, to call the new tree, or to make a new tree, you have to make a symbol frequency packet, a left tree and a right tree. Left tree, of course, always being your min tree, right tree being the second min tree. And your new pack was created from the symbol frequency packet. And you're going to place your new tree at the very end of your run through. So if we just run the little thing here, I'll be stepping a lot. So this is your initial forest. For some reason my BlueJay just hasn't been posting, like it's invisible. Yeah, it's weird. Anyway, so just out of memorization, T is the one with the lowest frequency and L is the second lowest. I believe T is 2 and L is 3. And once you combine them, you should get T on the left, just like I said, T being 2, L is 3. Creates a new one, call it like LT, and its frequency is 5. And the next two frequencies that should be combined next is C and H, because they're both equal to 4. And what's going to happen is this is going to swap over here, and the new combined tree is going to be at the end, like that. And basically you just keep doing the same thing. S will be the next lowest, and E is saved for last. Okay, and that's the combined trees. Now for encoding the tree, this sounded pretty easy. Basically, you're just taking in a character from the message and you're just translating that character into a set of binary, like bits, I guess you could call it. I don't actually know the real name. And you get it from the big tree that you made out of combining it, which is technically my tree 0. And basically you're just saying if the left child of that tree contains the character that you're looking for, you add a 0, because when you go to the left, it equals 0, I guess. And then if you go to the right, it's 1. And you just advance your, I guess, your current node of where the tree is to the left, and then you recurse it by calling it again. You can't really do coder.left because the Huffman tree doesn't have a left or a right, so you just have to use the advanced left method. And it's the same thing for check right, except this time it's 1. And if it's the symbol that you're looking for, basically, since left or right don't have the character you're looking for, you just reset the tree so that you start back at the top. And animation pause, of course. And in the application, the execute application method, let me see here. I'm basically just using an iterator to get each character specifically, and you set it into the code char equals message.next as long as my message has next, and you just keep calling it until you get the numbers. Same with combineTrees, you keep calling it until you only have one tree left. And if we run it, let's see, step. Oh, there you go, works. Should be going to C, which is 1 1 1 0 1 1 0, and yeah, perfect. And yeah, that's as far as I got.